everyone, see you again with me Tanti. In this video, I will explain how to make an electroscope and how it works. What do you know about electroscope? So, an electroscope is a scientific tool which helps in detecting the presence of an electric charge on a body. Now, to find out more about electroscope, let's watch this video.
To make an electroscope, for the first step, we need to cut our aluminum foil with our scissor. Here I'm using size 2 x 1 cm. So we just need to fold that one, so we could cut 2 pieces of it. And then we are going to put a hole at the top of our aluminum foil. I have already cut the top of aluminum foil, so we just need to set aside that one first. For the next step, get our copper wire. Twist the top into a spiral or circle to create some surface area. And then on our glass lid you can make a hole in the center of it. Now we are going to put our copper wire on the glass and create a hole about 2 cm long. After that, hang 2 small pieces of aluminum foil on the hook. Place the hook end of aluminum foil into the glass and tape the lid to the glass using electric tape. And finally, our electroscope is ready to use. Now, it's time to give our materials a static charge. Here I have plastic mica and I wrap it with the towel. And after that, I will bring each object near the copper wire. Now, the reason right here is when you wrap the plastic with the towel, electrons will transfer into the plastic down to the copper wire and to the aluminum foil. At this stage, both pieces of aluminum foil have become negatively charged. And since negative charges repel negative charges, this explains why the two aluminum foils spread apart. Now, I will do an experiment related to the effect of the distance between the mica plastic at the charge source and the copper wire on the distance between the two aluminum foils. To make it easier, I will ask one of my friends for help. In this experiment, the area of aluminum foil was fixed at 2 square centimeters, while the distance between the plastic and copper wire was made different by a difference of 0.5 centimeter. For this first experiment, the distance that I use is 0.5 cm. There will be 6 different distances and each distance is repeated 3 times the experiment. In this second experiment, I used a distance of 1 cm and aluminum foil has not shown a significant difference with a distance of 0.5 cm. Then, in the third experiment, the distance between the plastic and copper wire that I use is 1.5 centimeters. In the fourth experiment, the distance used is 2 centimeters, and in this video, it can be seen that the distance between the two aluminum foils is getting smaller. Then, for the fifth experiment, the distance between the plastic and copper wire is 2.5 centimeters. And it can be seen that the motion or distance between the two aluminum foils is smaller than the previous experiments. And for the last experiment, the distance is 3 centimeters, and it is very clear that the distance between the two aluminum foils is much smaller than the previous experiments. So it can be concluded that the distance between the charge source and the copper wire is inversely proportional to the distance between the two aluminum foils. The greater distance between the charge source and the copper wire, the smaller distance between the two aluminum foils, and vice versa. I think that's all from my video. Thanks for watching and see you!